Hi guys, I'm finally back with with Kotlin, Learning Kotlin Live episode 44. So basically, I'm going to, my plan today is to read you guys generics again because I've just read it again, and I hope that this time I can explain it better, a lot better this time. So yeah, let's start with probably what generics are. So basically generics are a way that you can avoid writing duplicate codes. I mean duplicate lines of code that do exactly the same for different types or different objects. So take this for instance. We have a box. This class is a box which wraps a value. So it can you might want a wrapper class to wrap a wrap an instance of any object. So it might make sense to wrap an integer. It might make sense to wrap a string or anything like that. So this is when you use this. Um, is that called a diamond? I think it's called a diamond symbol or diamond operator. What's the name of it? Can't remember exactly, but so you enclose it with these two diamonds, and that's it. So you can use this t the um and the parameter of the constructor or any function, and you can use it as the return value of any function as well. So, or you can use it to declare a property. So basically, just like Java, you can invoke a box of integer of 1, and because this integer is inferred with this 1 here already, so we can omit this integer bracket here. We can simply just call box 1, while in Java we call a box left bracket, left diamond, right diamond, and we still need that, but in Kotlin it's totally omitted, which I think makes perfect sense. So there's another idea that is called variance, which was designed to resolve through the wildcard in Java generics. And so there are two types of um, variants that we want to, or two types of relationship instantiation in Kotlin, and they call it declaration side and use side in Kotlin. So let's see. So yeah, this is a blog which I found that perfectly explain what declaration side and use side variants are. And for instance, if you are already familiar with the Java extends A and super B syntax, then it is a use side variance because this relationship of actually I should have explained what variants are first. So okay, so this is the story. There are instances like well in Java the generic types are invariant. By invariant we mean that a list of string is not a subtype of list of object. Why? If these are was not invariant, then there are some troubles which we can witness from this code fragment. Let's look at it. So basically, if let's assume that we have a list of string. If list of string is a subclass of list of object, then we can point objects. We can point a list of object to a list of string. So we can also put any object into this objects of list, which makes no sense because it is declared as a list of string. So in this example, it tried to illustrate that when you try to call strs.getZero, you get a class cast exception, but actually it's already problematic when you try to add something into the add an integer to a pointer or to a class which is actually declared as a list of string. So anyway, we still want to do things like this, but we don't want to we still want to do things like this. For instance, we want to have an add-o which take a collection of E of items. Well, it wouldn't be. So to prevent this, to prevent these from happening, Java actually treats generic types as invariant, which means that a list, again, which means the list of string is not a subtype of list of object. So here comes the problem. If we have, say, we have declared an interface of which is collection, which probably you are already familiar with, and we want an add-o function for it. And if we try to call add-o with a collection of object and add everything from the collection of string, it's perfectly okay and safe because string is a subtype of object, and so it is definitely okay to put strings into this collection of object. But because it is invariant, because Java treats generics as invariant, this is not allowed. So this is when we need to tell compiler some extra information that actually this is perfectly safe. So this is achieved by this extend E syntax in Java, which is something that we just mentioned as the use side variance. We're going to see why this is called use side variance after we introduce something that is only unique in Kotlin, or actually originally from C#. So, okay. So in Kotlin, there's something that is called declaration side variance. And this is again illustrating that there are cases we know that are perfectly safe there are specific operations we know are perfectly safe in Java. For instance, so this out keyword is a way you can tell compiler that, okay, with these interface or these classes, I am only using this class. I am the generics that where I am going to use these generics are restricted by some certain constraints. So this T only happened to be shown in the return type of functions of member functions of source. So we call this out, which is called that t is a covariant type parameter, or class C is covariant in the parameter t. So that means that actually every time we're calling using this next of t, it is okay to assign subclasses of an instance like source of any, because string is a subclass of any. So it is perfectly okay to assign source of string to source of any. So it is okay because we know that we won't call a function, so we only read from this source because only things are returned from this source. We never pass in a parameter of type t, so the t is always safe to be point to something that is of the subtype of the declared source. So this is called the declaration side variance. We can see it here. So like an iProducer of out, it's covariant, or we only put it in the return type. And iConsumer with or contravariant, this t is only used as the parameter that is passed in. So because of these constraints, we tell the compiler that please allow me to do some something that should be allowed. Like for instance, we want iProducer A, producer of A, to be point to producer of B, which was illegal but is now legal after we added list in keyword. Actually, it's a producer, so this out keyword. So the out and in is pretty much just the opposite. You can see from here, it tells that okay, so it's safe to point to some subtype, or it's safe to point to some supertype. So this is called declaration side variance because this relationship is declared at or this constraint is set up at the declaration of the class itself. This is opposed to use-side variance, which you only when you use the class you declare the relationship. You declare that question mark it stands A so that something is legal. And similarly, you declared question mark super B so that some operation now becomes legal. And both declaration side variance and use side variance are allowed in Kotlin. Well, maybe just not in the Java syntax, nor in the C# syntax. So let's move on. That's what we discussed in this part. And type projections, yes. So there are cases, I really don't like this. Oh, actually, this is, so we talk about the declaration side variance in this part, and for type projections they are use side variance. So basically, it's just the same old concept we use here for Java, and now, oh, oh, actually, it's a lot specialer than what we see here with Java, because these use side variants and declare side variants are all modifying the behavior of an instance of a specific generic type. But for type projections in Kotlin, we are actually decorating, or what should I say, modifying, decorating, modifying, or I need a better phrase, but annotating, maybe. So you are actually telling more info about a function parameters rather than some instance of generic type. So let's see where we will going to need this. So basically, sometimes we just can't modify this or annotate this t here, because the t is used in both the return type of a function and is also used sometimes in a parameter as a parameter type of a function. Because, for instance, the array type, the array class, we're definitely going to set it and get it. So it's going to be served both as a consumer and a producer. So let's see. So sometimes we annotate the function instead. Like, for instance, sometimes we know that we're going to again copy from array of any to array of any. So nope, this is not going to work because actually, is it? I don't think so. Yeah, because when you use this, you don't actually always pass in an array of any. You might pass in an array of integer, and sorry, so there's going to be a compilation error. So again, so this is for situations like this, we can illustrate the relationship between these two classes, these two parameters of a function. So this is called type projection, and it is only used when there are like more than one generic type is passed in, maybe. Or let's take a look at this array of Kotlin. And get function and set function. Okay, nothing is. Oh, they are actually getter, and they are actually operators, so they are something that are special, but I don't know. Out dices. Okay, because these are extension functions. Okay, I don't quite get it now yet, but anyway. Well, yeah. So what is this making? I don't quite really get what this add ups to the what are the things that were illegal before we added this? syntax are now legal. That is something that I am not aware of. So actually, let's see. So yeah, but the thing that I can tell so far is if there are a pair of parameters which both are or maybe more n tuple, which all of them are many or at least two of them are using are wait. Okay, I get it. Maybe. I hope I do. So basically, what you gain here are not something that you can point it to something. You can reassign it to something. No, not the type exactly, but you can assign it inside. You can assign something inside the function, this function itself. So, star projections. So, wait a moment. Star projection. I'm a little bit, this means there are cases that you would like to declare a generic type of instance of star, which basically means that you don't quite care what the actual type of this is. So you might want to do something like foo function, and it takes a t of type foo of star, so that you can call some foo related functions in this, such as t.sort or t.hashcode. Anyway, well, wait. So, assuming there's a function for type or for class foo, there's a function that is called bar, and yeah, this is an example of something you might want to do. So this part, star projection, are actually telling you explicitly that this thing is just basically just like the row type in Java, and sometimes you do use row type this way. You don't care about what actually the class it is wrapping. So, but there are some functions that are related to this foo class, and yeah, you can call it. But Kotlin actually made these row types a little bit more, a little bit safer. And for instance, that for a class that you declared, if you declared foo of, actually I need to talk about this syntax first. So, generic constraints. Sometimes you know that a class T is always of an instance of specific class comparable T or whatever. You can annotate the function this way. But this is a function. Sort. Wait. Okay, because you want a comparable to be able to be sorted, so yeah, so you can declare that this T needs to be something of comparable so that it can be sorted. And we declare a function that is called sort. Is this an extension function? No, it's not. It's just a function of sort, which, well, I wonder what happened if we create a instance of a function that is the enclosing class of this function. Is it going to be compile file, or anyway? Okay, let's take a look at some. It's not talking about the declaration of the class. That's interesting. So that's the, yeah, okay, it actually talks about it. So if you pass in sort of that, there's going to be a compile time error. So this is some way that you can annotate a function or annotate a generic class so that only specific type subclass of a or implementation of an interface can be passed in. The default upper bound is any blah, and if you want to have multiple constraints, you can use this where keyword. So again, let's get back to the star projections. So now we know that this is a constraint of a generic. So if you have set up a constraint and annotate the t with an out, so when you instantiate a foo of star, this foo of star is actually equivalent to foo of out of t upper. So you can only safely read, but you cannot write to it. This is different to the behavior of Java row type, row generic type. So similarly, if you declare a foo of n of t, it is equivalent to foo of n of nothing. So you can't write anything safely to this t when t is unknown. I mean, when where t is unknown, it means that when you're using a foo diamond star. And similarly, if you don't have that out, even if you don't annotate it with this out here, it is still equivalent to foo out t upper. So, and furthermore, because you are not adding any in or out modifier on this t, so it also means that it is for writing it is equivalent to foo of n nothing. So basically this is just the same. This is nothing particular. So this is just telling if there is an interface of function int out u, function of star means function and nothing out any again. So this is just like the safe Java row types. What else? Okay, so there are generic functions as well. So this is actually the generic function which I failed to talk about first, but for generic functions, the syntax are function and you have a generic type of it so that you can pass something that are related to a type, like singleton list. You pass in a t and you return a list of t. That's some way that you can annotate a function, and so that you can have the convenience of using generic so that you don't need to write a lot of functions. So again, it can be inferred. This is nothing special. Generic constraints, we already talked about this. So the last part would be type erasure. So I'm going to skip this part actually because this is actually something that is deeply tied to the implementation of Java JVM. And well, the basic idea behind this is generic types are we need all these information to make things safe because Java in a JVM bytecode, all generics instance are type erased. So yeah, so that is why we have unchecked cast exception because at runtime Java don't know anymore about the type of these generics, and this is also exactly why these techniques are so important because they can help us identify problems at compile time. And if you want to pass the type in, there are a specifically designed way to do this, which are the reified type parameters of inline functions. I'm not going to go deep into this, but I think I have talked about this in the episode, I guess 26. But episode 26 is illustrating the whole generic idea in a very obscure way because back then I was still learning about it. Even now I'm not 100% what I am talking about, what I am trying to tell you. No, sometimes I just talk as well, but I hope this episode 44 is a lot clearer than what I have done in episode 26. So basically that's all for today, and yeah, thank you for joining me today, and I'll see you again tomorrow with some Kotlin coding. See you tomorrow then. Bye bye.